Alright, here's our sample problem I want to work, and remember I want to do it using this guess method. Let's read the problem. In 1954, Colonel Stapp did a variety of tests for the military to determine the limits of the human body under extreme acceleration. This is a true story, by the way. You can view this video on YouTube. In fact, I showed it in class if you were there. In one rocket sled test, he went from 1,020 kilometers per hour to rest in the small time of 1.4 seconds. What acceleration or deceleration did he experience as he came to a stop? First of all, this term right here I probably should not include. We don't use this term in physics. What acceleration did he experience? It could have been slowing down, it could have been speeding up. Acceleration is all the same. So let's use the guess method to solve this problem. First thing I'm going to do is start with my G. What am I given in this problem? Well, I'm going to look through here, and I see a number here and I see a number here. Those are going to be some givens for me. So let's go to this one. 1,020 kilometers per hour. I know that is a velocity. I also know that he's changing his velocity in this problem. He goes from 1,020 kilometers per hour and he ends up resting, and this speed is 0. So I know that 1,020 kilometers per hour therefore will be my initial velocity. My initial velocity is 1,020 kilometers per hour. And the thing we need to do when we do givens and unknowns, in the G part, we do any unit conversions for the G. So let's look in the number that we have right now, 1,020 kilometers per hour. And the question is kilometers per hour in the units that we need it to be in? And the answer is no. We don't want kilometers per hour. We need to take this to meters per second, and it's very important that you know that from here on out, all speeds in this class must be in meters per second in order to enter them into an equation. So I want to change these units. I'm going to do it right now so I don't forget about it. 1,020 kilometers in 1 hour. To convert that, I get rid of kilometers by putting it on the bottom. Kilometers needs to go to meters. That's the unit I'll have on the top. And there are 1,000 meters in 1 kilometer. Meters is what I want on the top, so I'll circle it and circle it over here to tell myself I'm finished with the top unit. Now I'll work on the bottom. Hours has to be gotten rid of, and I'm going to go to seconds. To get rid of hours, since it's on the bottom here, I'll put it on the top over here. Cancel, cancel. Seconds goes on the bottom. 3,600 seconds in 1 hour. Seconds is what I want, so I'm done. Meters per second, meters per second. 1,020 times 1,000 divided by 3,600 gives us a speed of 283 meters per second. So that's one given. Another given, here's another number, 1.4 seconds. Well, that's a time, so I'll say that my time is 1.4 seconds. And that's good. We need time in seconds, so those units are okay. And I also know if I have an initial velocity, I'm going to need a final velocity, and we already mentioned that this rest is 0. So my final velocity, or his final velocity, will be 0 meters per second. I'm not given anything else in the problem. Next, I'm going to go to the U. My unknown in this question is the acceleration. That's what they want to know. What acceleration did he experience as he came to a stop? So the equation, you might have guessed, is the one that we've been working with today. The equation is A equals VF minus VI over T. And ordinarily, to pick an equation, what you would do is look at what you're given, VI, T, VF, and they want A. You look at all those things, and you would find an equation with that stuff in it. And lo and behold, here it is. Next, the first S, we're going to substitute everything in. So our final velocity was 0. Our initial velocity, we figured out, was 283 meters per second, not 1,020. We cannot enter this number into the equation because it's not in the correct units. must be in meters per second to put it in this equation. And the time is 1.4. The last S we'll go to here is to solve. 0 minus 283 gives you negative 283 divided by 1.4, and if you work that out, you should get an acceleration of negative 202 meters per second squared. That's the amount of acceleration that this man experienced. And that's an amazing amount of acceleration, because if you compare this to the acceleration due to gravity, which is 9.8 meters per second squared, you'll find that this acceleration, well, this would be negative also, this acceleration is about 21 times greater than what this is. Which means that as he was experiencing this acceleration, and he was feeling like it was as if he weighed 21 times more than what he did. That's an incredible amount of acceleration, and you'll find if you watch that video that his body was almost not able to withstand it. So that's acceleration.